Hello friends, welcome to aTech. For those of you who don't know us, we have a habit of offering exciting and unpublished videos. Today again, we will present to you a topic that concerns the great constructions that made by man. In this part in particular, we are going to look at bridges built over water. We'll see first of all how they are built, but also the technologies used to build them. Stay tuned to the end of the video to understand everything. Bridges are structures that have great changes in the history of humanity. They have connected cities, regions, and other continents. All of this is thanks to ingenuity in the agriculture and technology prowess. Rivers and even seas are no longer obstacles thanks to their construction. But the greatest achievements of mankind consist of connecting two lands separated by a huge river or sea. But why exactly are we talking about a feat in this case? Well, unlike bridges that connect places separated by a shallow river, bridges over the face many constraints. First, there is a distance to consider. It can even reach several kilometers. In addition, the water is much deeper. In this case, placing a support between two lands is no longer enough. We must consider other engineering systems that offer much more effect. But several problems can arise. In fact, for saltwater construction, engineers must design supports that are also corrosion resistant. They also have to think about the pressures that keep increasing with depth, and don't neglect the structures so that they resist waves and wind. It's no small task, is it? So, how have engineers managed to build bridges over water despite these constraints? It all starts with a choice of metals that allows the infrastructure to be strong. Having a long enough lifespan is also a priority. In general, the choice revolves around these three metals: concrete, steel, and plexiglass. High-performance concrete goes hand in hand with a crack prevention technique. For example, a bridge-resistant fatigue cracked by using concrete slabs. Steel is a very strong and resistant metal. Plexiglass allows a variety of structures, with a neat aesthetic aside. But no less, it's solid. But in addition to the choice of materials, it is also a necessity to choose carefully the techniques of construction. They also should be more suitable for each situation. For this, the choice is wide. Engineers can choose between techniques that allow to build a bridge without moving the water and those that allow to work in a dry environment. Let's see how this first technique is the most cost-effective. It consists in using piling systems. With the latter, there is no need to move or divert water. The construction is done directly on it. However, steel columns are placed in the water to support the bridge. A hammer is then used to fix them more solidly. Once stabilized, the hollow part of the steel columns is filled with concrete. The goal is to have good foundation for the bridge. The particularity of these concretes is that they can solidify even in constant contact with water. This ingenuity was born in Roman times, and has been improved to adapt to modern constructions. It guarantees a solid structure and allows the bridge to resist all stresses in the water. Another solution can be used to build a bridge over water. This includes the use of cofferdams to dam up the water around the construction site. This process allows the workers to work in a drier area. The technique is used in various projects such as construction of dams, the repair of large ships, and many others. In fact, it consists of surrounding area where work is to be done, then pumping out the water in the area. Even if it's just temporary, it's more complicated to install. So to keep costs down, engineers often choose materials that are available near the worksite. For example, a cofferdam can be built with bags of soil, but the problem of this type of installation lies in the evacuation of the water. Indeed, it is difficult for workers to build cofferdams that can reach such a depth. In order to overcome this problem, they must use pumps capable of evacuating the water quickly. This process can be very expensive for the construction company. For this reason, most engineers only see this technique if other techniques are not feasible for construction. Another technique is the use of caissons. This is one of very common in the most construction sites today. It allows you to work on dry environment without having to move water. For those unfamiliar, caissons are structures that are watertight even when they're open. They are placed in the water until they reach a solid surface that can support them. Three types of caissons are most commonly used in this type of situation. These include open housing, enclosures, and pneumatics. Open caissons do not have a bottom. This makes it easier for the workers to work. As for coffers, they have a foundation that workers must build beforehand. And for the pneumatic caissons, they allow to maintain the same pressure inside and outside the foundation. In other cases, some engineers use pre-assembled caissons. These are built off-site by specialized companies and then transported to the site to be placed in the water. Generally, these caissons fall directly underwater under their own weight. This technique is now widely used. It is more efficient and easier to install. The Rayon Bridge is located over the Gulf of Corinth in West Greece. Connecting the Rio to the Greek mainland over the Gulf of Corinth has been a dream for over a century. Unique solutions have been found. For example, the construction of a span of about 2,252 meters long to withstand extreme conditions. The bridge is even capable of surviving earthquakes of up to 2.7 on the Richter scale. As for resistance, it does not disappoint. It can withstand winds of up to 260 kilometers per hour. Experts even say that the bridge can be a safe place for during an earthquake. But the good news is that vehicles can now cross the Gulf of Corinth in 5 minutes instead of 30 minutes by ferry. Such arrangements allow the water to be cleared for a few hours. This can leave more room for larger ships. But what is really incredible is the way it is built. To build the bridge, the subsoil under each pier is reinforced. Using hollow steel cylinders of 25 to 30 meters in diameter were driven into the ground. For the caissons, built 90 meters in diameter, are the largest ever built before. The total cost of the project was about 800 million euros. The whole project was launched in July of 1998 and completed by May of 2004. In contrast, the longest bridge ever built remains the Hong Kong-Zhuhai Bridge. The bridge is 55 kilometers long. It was built in 4,000 tons of steel. That's enough to build 60 Eiffel Towers. But this bridge does not serve by public transport, so private shuttles make the trip. In the past, traveling between Zhuhai and Hong Kong took up to 4 hours. But the new bridge reduces that time to 30 minutes. After it opened in 2018, authorities estimated that 9,200 vehicles would cross the bridge every day, but then lowered their estimates after new transportation networks were built in the area. In short, technology is constantly evolving. Humans are constantly pushing the boundaries of construction. Soon, more inventions will emerge to take humanity even further. That's it, folks. Our video is coming to an end. We hope you enjoyed it. If you did, leave us a little comment, and don't forget to subscribe to the channel and activate the notifications to be aware of our next topics. A little like from you will also make us happy. See you soon for another topic on aTech.